Hi everyone, my name is Dustin. I'm a math tutor. I have a YouTube channel. It's called Dustin's Fun Math, and I really appreciate if you can take a look at my videos and let me know about if you like it or not. And if you have any questions, let me know. And if you like my videos, if you can subscribe, I would really appreciate it. I have another fun math problem with you guys. So it says one log of 2 to the power of x minus 1 in the base of 2 and log of 2 to the power of x plus 3 in the base of 2 are consecutive terms in an arithmetic sequence. Find the value of x. So it's giving us a hint here, this problem. So since these terms, we have three terms, and since these terms are consecutive terms in an arithmetic sequence, we know that their common difference is going to be the same between two consecutive numbers. So I'm going to write this as log of 2 to the power of 2 to the power of x minus 1 minus 1 is going to be equal to log of 2 to the power of x plus 3 in the base of 2 minus log of 2 to the power of x minus 1 in the base of 2. Now we have a relationship. When we are looking for an unknown, you need to have an equation. So now we have our equation is a logarithmic equation, and we have the same basis for all of them except the one here. So we need to make sure one is in terms of log. So to do that, simply I can substitute one the log of 2 in the base of 2. I can write it that way. So everything is in log. So I'm going to rewrite this as log. We're going to use quotient rule in logarithmic functions. I have 2 to the power of x minus 1 divided by 2 in the base of 2. This one I have log of 2x plus 3 divided by 2 to the power of x minus 1, right? And this is in base of 2. So because I have the same basis with log in both sides, their expression is going to be the same. In order to have both sides equal. So what I'm going to do, I'm going to write this as 2 to the power of x minus 1 over 2 equal 2 to the power of x plus 3 over 2 to the power of x minus 1. So this one is a little bit tricky. Since we have 2 to the power of x and we want to solve it for 2 to the power of x, it might be a little bit challenging to just solve it just the way it is. So if you're going to do a trick here, I'm going to substitute 2 to the power of x with a variable t, and then I'm going to substitute back in this equation. So let me, we have a space up here. So this is going to be t minus 1 over 2 equal t plus 3 over t minus 1. So now things looks much simpler to solve it. So let me get rid of, let's see what I want to get rid of. These are all important. For now, I don't want to get rid of that. So let's get rid of this this description here. We know what we want to do. We want to find the x value. We know these terms are consecutive arithmetic sequences and so forth. So now I can use cross product. So I'm going to write this as t minus 1 to the power of 2, right? T minus 1 times t minus 1 is t minus 1 to the power of 2. And then 2 times t to the power, 2 times t plus 3. So it's going to be like this. Then I'm going to expand the t minus 1 to the power of 2 is going to be t squared minus 2t plus 1 equal 2t plus 3. I'm going to rewrite this as, therefore, this is going to be t squared. This is going to be negative 4t. And this is going to be negative 2 equal 0. So, oh yeah, one mistake I made here. Sorry guys. So this is actually 2 times 3 is 6. So this becomes, let's see, negative 4. And this becomes negative 6. Negative 6. And we have 1, negative 6 with 1 is actually negative 5. Sorry guys. This is going to be negative 5. All right. So now this turns out to be t. We're going to make it in a factor form. It's going to be negative 5. It's going to be t negative 5, t minus 5 times t plus 1 and equal to 0. So based on product zero property, we're going to equate each parenthesis to 0. So I have t minus 5 equals 0. Therefore, t is equal to 5, right? And then t plus 1 is equal to 0. Therefore, t is going to be equal to negative 1. Are we done yet? No, we are not done. We need to plug back these t's in this equation that we had here. 2 to the power of x equal t. Remember, we chose a variable. So let me get rid of some of the written on the board. One. So this one here, I'm going to put the arrow here. So the first is going to be 2 to the power of x equal negative 1. So for any value you put in here for x, you will never get a negative number. So it's always a positive. So this is not acceptable. The next one is 2 to the power of x equal 5. We want to bring x down to have a linear equation to solve for x. So we're going to use the technique of taking a log of 2 to the power of x in the same base, in the base of 2. And then also you take a log of 5 in the base of 2. The reason I chose base 2 because I can bring the x on the behind the log, and you have log of 2 in the base of 2, which makes it 1. So this becomes x of log of 2 in the base of 2 equal log of 5 in the base of 2. Log of 2 in the base of 2 simply is 1. So x is equal to log of 5 in the base of 2. You can leave the solution as log of 5 in the base of 2, but if you want to get a precise solution, you're going to use the change of base formula. So I'm going to write this as log of 5 over log of 2. And we know their bases can be any base as long as they're the same. I'm going to choose 10. And usually in log with the base of 10, you do not write the 10. That's how mathematicians want it to be. So log of 5 divided by log of 2, you use a calculator, and this becomes approximately 2.32. How do I know that? I already calculated with the calculator. Yeah, so it's gonna be 2.32. That's the solution for x. If you like this math question, please leave me some comments, and if you have any questions about it, let me know. And looking forward to see you guys for another episode of Dustin's Fun Math with a fun problem to solve. Have a wonderful day and see you guys soon. Bye bye.